Hey guys, in this video we're going to be going through chapter 3 on polynomial and rational functions, and in section 4 we're working on the graphs of polynomial functions. So we're doing problem 27, which says use the intermediate value theorem to confirm that the given polynomial has at least one zero within the given interval. And our function is f of x equals negative x to the fourth plus 4 between x equals 1 and x equals 3. First step, we need to know what the intermediate value theorem is. So the intermediate value theorem states that if f of a and f of b have opposite signs, then there exists some c between a and b such that f of c equals 0, which is what we're looking for. We're looking for at least one zero. Okay, so what we need to do is we need to plug in values for a and b into our equation here to get f of a and f of b to find opposite signs. So I'm going to choose f of a. I'm going to choose a equals 1. And when we do that, we find that f of a equals negative 1 to the fourth plus 4, which equals 3, which is greater than 0. Next, I need to choose a b. I'm going to choose b equals 3. Since those are our endpoints are 1, 3. This is our interval. And I just plug that in to get our interval of a from a to b. So our b is 3. And we have that f of b equals f of 3 equals negative 3 to the fourth plus 4, which equals negative 81 plus 4, which is negative 77, which is less than 0. So here we have that f of a is greater than 0, which is positive. We have f of b, which is negative. So they're opposite signs. So we know that there must be a c between a and b. In other words, there exists a c There exists a c between x equals 1 and x equals 3. Such that f of c equals 0. And there we go. I hope you found this video really helpful. The concepts we covered in this video are true no matter what pre-calculus class you take, and the examples I cover are from this textbook right here. And remember, if you're a Baylor student currently enrolled, there is free tutoring on the first floor of Sidrich. You can create a one-on-one appointment online or drop in anytime during our business hours. Please visit our website, www.baylor.edu/tutoring, for more details. Sic 'em Bears.